Hello, welcome to the lecture of control system and instrumentation. I am Mr. Prajit from Asansol Engineering College. Like to giving you some ideas, especially some introductory ideas about control system and instrumentation. So, control system, about control system, when I like to speak about that, that is very much essential with respect to our household, in appliances, for whatever else it may be. We will see on successive examples, and that thing is very much known to us, but we have to know the relevant principle about the same. And before starting this subject, I need to tell you people, you should have a sufficient knowledge about the complex algebra, complex analysis, and Laplace transform, because control system is entirely depending on Laplace transform, especially that is S domain. S consists of sigma and j omega. That means sigma is my real part and j omega is my imaginary part. That's why j is equal to root under minus 1. So successively we will see all those things, and it is highly anticipated you have a sufficient knowledge regarding those things, because mathematical skills are highly essential here. Now, the respective outline of this subject is what is the control system, what are the types. Actually there are two types of control system, that is open loop control and closed loop. That means feedback control, that thing we will see successively, and development, how the control theory is developed, that thing should be known to us. And feedback, when I am speaking regarding the closed loop system, and you people have studied in analog electronics, especially in case of feedback amplifier, so that concept is remaining same. Here we will see in elaborate way. Okay, now what is the control system? The general definition is, it is a device or a set of devices to manage, command, direct or regulate the behavior of other devices or systems. And control means feedback loop, that including sensors, it can be, or control algorithms and actuators are arranged in such a fashion as to try to regulate a variable at a set point or reference value. Okay, now again, if I am speaking regarding the typical feedback control system, that contains the key elements, and these are listed below, that is plant or process controllers, actuators, sensors, and all those things, and control objectives, obviously, that is to be performed. So what is plant? It is the object to be controlled. Controllers, devices that compute and generate control signals or actions. Actuators, devices that perform control actions. Yes. So sensors, devices that measure the output, and control objectives, that means tasks, targets of control, what thing we need to control, that is the control objectives. And one thing I need to speak, in control system we have to know the relevant terms, that is input term, input, output, all those things. Sometimes the input signal can also be called as a command signal, and output of a control system is known as the controllable output or control output. That should be known to you people. Okay, now we are focusing the open loop control system. Here see, the block diagram is highlighted, that is controller, process, corresponding sensor, it will sensing the respective output. Okay, so here the controller does not use measurement of system output being controlled, because there has no feedback connection, that's why this line is highlighted. And when computing the control action, that's why no feedback, just now I told you. Now see here, the command input, command signal is provided, and that signal will pass through a controller, corresponding control action will be performed, and the resultant of the control action will be processed, by which its respective output will be generated and it will be sensed by a sensor. Okay, now closed loop control, it is a feedback control system, obviously name itself signifies meaning, the control system output is measured. Obviously, with respect, if you are comparing this diagram with the previous one, you can see this thing here. See, the control system output is measured and being used for computing the control action. So what components are added previously with respect to the previous diagram? Here see, we are using an error amplifier, that is error, it is highlighted, that is controller is obviously there, actuator, between controller and process actuator is inserted, and sensor, obviously it is the feedback element, it acts as a feedback element. And here see, we are providing negative gain, but that gain can be positive also. If the gain is negative, then that feedback is known as negative feedback, and if the gain is positive, then the feedback known as positive feedback. So that's why we can speak negative feedback is known as degenerative type feedback, because it maintains stability but the gain is becoming reduced, whereas positive feedback is known as regenerative type feedback, where gain is to be raised but the stability is going to be minimum. That means that system can become unstable. Okay, so here see, this is the respective block diagram. Here when the command input or command signal will pass through the error amplifier, and the sensor which generates the signal by which the error element, that is the error signal, will be generated, and these error signal will pass through a controller, corresponding controller action will be performed, and actuator will process this control action by which the respective output will be generated. Again, some portions of the output will fed to the sensor and correspondingly the error will be measured. So since such type of error can be handled with the with respect to the input signal, that's why it is known as the feedback control system or closed loop control system. So in practice, we will see the feedback control system generates highly stable. We will see successively. Now, when I am speaking regarding room temperature control, that means room temperature control means that is very known to us, is very household appliances, home appliances. See here, open loop scheme, switch, obviously that is my command, on or off state, and when it is switched on to the pulse is entering to the furnace and corresponding inlet vent will be heated and the room is heated, so on, and the temperature is raised. Here see, this is a type of open loop system. Obviously there has no measurement for feedback and control action is remaining fixed, can't adjust to unexpected changes from the system environment. Actually, open loop system is nothing, whatever the input is provided, that should be available as an output, provided certain disturbances can be made, certain actions can be made with the help of the internal components only. Otherwise there has no feedback connection, that's why you have no right to control the input. Okay, so that thing is not at all acceptable. When I am using room temperature control in the sense of closed loop scenario, in the sense of closed loop scheme, see here I can use the thermostat. Here I am utilizing one unity feedback system. Obviously I can do it, unity feedback system. So here the desired temperature thermostat, that means I have to regulate that thing, that is depending on my regulator what temperature I wish to generate, and that after generating of the temperature, that output will flow through the furnace where the inlet heat will be generated and room will be heated, and another external thing is heat variation can be going on externally, and correspondingly room temperature is generated, and that room temperature can be controlled with the help of thermostat. So here thermostat, what is the job of thermostat, what is the working principle of thermostat? Here thermostat works to sense plus controlling device, that is the nature of thermostat, and automatically adjust room temperature, can easily change room temperature as desired. Another very practical example or live example I can speak about to you people. All of you have the ceiling fan. So in case of ceiling fan, see, when a regulator is not there, whatever be the input, whatever the speed is fixed to the concerning fan, that will be going on. That means I can't regulate. I can't, if the speed is maintaining high, it will be high. If that speed is maintaining low state, that is in low state. So that type of system is known as an open loop control system. When I am when I am making a regulator to regulate the speed of the respective fan, that means from 1 to 5, that I am moving the notch. I am moving the notch from 1 to 5. That means I am increasing the speed of fan maximum to 5, or I am reducing the speed from 5 to 1. That means I have a controlled about the speed of a fan. Obviously, when the regulator is present to control a fan or ceiling fan or whatever else it may be, then we can speak that system is closed loop system. So that is a very prominent example for few people. Okay. Now car cruise control, another thing that is also see here, the feedback control system or closed loop control. Here see control unit where the desired speed is to be known to us, what speed I need to do, whether 60 km per hour, whether that is 40 km per hour, 80 km per hour, that is depending on the respective driver who is controlling that thing. And correspondingly that output will be fed to the engine, and it will be, that output will pass through a car body where the road grade is another external input that should be available on the car body, by which the corresponding speed is generated, because sometimes road is not smooth, sometimes road is smooth, so that thing should be on the driver's mind. Correspondingly we have to manage the car in such a way, if the road is very smooth then we can increase the speed, if the road is rough we have to reduce the speed. That's why we can see some portions of the output of a speed will pass through a speedometer, by which the controlling action can be going on. This is one other very good example, that is car cruise control, that is also to be known as the closed loop car speed control. Here control mechanism is going on with the help of the differences with the help of the difference between the set speed and the actual speed. We have to compute that thing, then open throttle according to the quantity of error. Okay. Now human balance system, yes, we are standing, we are moving, all those things. Just you think, when we are closing our eyes and we need to walk from one place to another. Okay, I know that there are some obstacle, previously I have seen it, but sometimes I will feel, where can I go, where I have to move, because my eyes are closed. So on that movement, that is the blind movement, is known as an open loop control system. Now when I am opening my eyes and I need to move from one place to another place, I have a sense in my brain that there is an obstacle, I have to avoid that thing, there is the right path, that is the wrong path. So lot of decisions can be made with the help of our brain's computer. Okay, so that is brain. When my eyes are opening, that means it's sensing something. That means when the error is occurring, we have to reduce, we have to avoid such type of disturbances, such type of things which may happen, some accident. We have to avoid such type of accident during walking or during driving, all those things. So that is known as the closed loop system. That means everything will be under supervision. So here see human balance control system, when I am telling to you people, that is brain, obviously the master operator, and the ankle, hip, foot, that means when you are standing here, obviously body is there, and some disturbance, that is a perturbation, is the external source, and the position, that is my output, where should I go, and the sensors are eye, inner ear, balance system, legs, pressure, etc. So if my leg is not so well, that is leg is weak, so how can I move from one place to another place? Then I will take the shortest path. So that decision should be taken with the help of my brain. So entire system is totally depending on the closed loop system, and we can balance. So if I am not controlling myself, then since my leg is weak, so after closing my eyes, I don't know where I have to sit, where I have to stop, so I can feel some accident. Okay, so that is the scenario. Here see analogy of the human balance control is ankle hip strategy, that is similar to inverted pendulum. Very good example with respect to control system. Inverted pendulum. Yes, here. And step strategy is the similar to inverted pendulum on a cart. So that thing is very good example for control system. Inverted pendulum and inverted pendulum on a cart. Okay. Now here the application and theory. Control systems and feedback control concepts are everywhere. Daily life, manufacture plant, aerospace industry, automotive industry, chemical, biomedical processes, obviously. The subject of control is multidisciplinary, obviously in engineering, mathematics, computer science, etc. And what is the history of the classical phase? Why do we invent? Why do the control theory is coming into the consideration for the industrial purpose, for the technology purpose? That thing. See, analysis based on mathematical modeling, one of the good thing, because we will see how to generate transfer function for that. And analysis of fly-ball governor based on non-linear differential equations established by or invented by Maxwell's on 1868. Stability notions, stabilizations, non-linear stability, that is coming from the concept of non-linear dynamics, Lyapunov, Russian scientist on the era of 1890. Gyroscope autopilot, Sperry, 1910. PID control, P stands for proportional, I stands for integral, D stands for derivative control, invented by Minkowski, that is on 1922. Now, frequency domain methods for analysis and design, obviously that's all these things are in your syllabus, that is we will teach on module 3 4 respectively. That is Nyquist plot, Bode diagram, feedback amplifier, that is invented by Black, Bode, Nyquist at Bell Lab on between the years of 1930s to 1950s. And key classical control methods are Routh-Hurwitz, that is RH stability criterion, Root-Lucas, frequency response methods, Nyquist criterion, graphical and hand computation, suitable for CISO, means single input single output, and low order systems. Okay. Now history of modern phase during the era of 1960. Computer control system, state space modeling based design, very good thing, that is highly sophisticated control system is known as the state space modeling. We will teach to you people at module 4 or module 5 respectively. We will see. Optimal control, Kalman filter, very useful filter, Kalman filter. We will see to evaluate the controllability, observability, all those things. Communication systems, network based distributed communication control system, that is DCS, etc. Modern control uses state based modeling and can deal with MIMO, means multi input multi output and high order systems. Related issues in control system: number 1 is modeling, obtain mathematical models. Number 2 is analysis, stability, time domain specifications, frequency domain specifications. Design, specify the structure and parameters of a controller to achieve the desired performance specifications. Implementation, analog filters, digital controllers, microcontrollers. PLC stands for programmable logic control. DCS is distributive control system, etc. Okay. So that's all for today's lecture, and these are the respective assignment. What is control system? Mention list of issues in control system. Explain in brief about a closed loop control system with relevant block diagram. That means you have to generate some example of a closed loop system. Okay, and these are the respective references. I am taking help from that. You can take these books also as you wish. Otherwise, you can study from any kind of books. So that's all.